Hey, very good morning, students. Let us see how to design asynchronous ripple counter. Or you may get a question like design a 3-bit ripple counter, or design a asynchronous ripple counter, or design a 3-bit asynchronous ripple counter, or up counter. So ripple counter is of two types. Asynchronous counter is of two types. One is up counter, other one is down counter. In this session, we will see how to design a 3-bit asynchronous up counter. Okay, so let us start doing it. You all know when I say asynchronous, it means a counter. First of all, a counter is used to count the pulses. So the job of counter is to count the pulses 0, 1, 2, 3. It counts the clock pulses. Now this counter is of two types. If it counts in upwards fashion, that is 0, 1, 2, 3, then you call it as up counter. If it counts in a downward fashion, n minus 1, n minus 2 till 0, you call it as down counter. Now we are going to design a up counter. Now to design that up counter, in asynchronous fashion, how the circuit should be. Since it is 3-bit up counter, you need 3 flip-flops. Clear? So if they say 4-bit counter, you should have 4 flip-flops. Now I've taken T flip-flop. So since it is 3-bit ripple counter or 3-bit asynchronous up counter, I've taken 3 flip-flop. Flip-flop 1, 2 and 3. What type of flip-flop I have taken? T flip-flop. So you know T flip-flop has T as an input, output Q. Input T, output Q1. Input T, output Q2. Okay. Now you know every flip-flop should have a clock. So in asynchronous counter, listen, in asynchronous counter, only the first flip-flop will be given the clock pulse. The second flip-flop will get the clock from output of first flip-flop will be given as a clock of second flip-flop. Output of second flip-flop will be given as a clock of third flip-flop. This is a construction. So what is the first step in the construction? Design a 3-bit ripple counter. So I need how many flip-flops? 3 flip-flop. Flip-flop 1, flip-flop 2, flip-flop 3. What type of flip-flop I'm going to take? I'm going to take a T flip-flop. T, T, T. So take all the inputs, T inputs, and connect it to 1. Now what is the next step? I'm going to apply clock only to the first flip-flop. Okay. Output of first flip-flop will be acting as a clock of second flip-flop. Output of second flip-flop will be acting as a clock of third flip-flop. Done. Now where I will take my outputs? I will take my outputs from Q0, Q1 and Q2 are my outputs. Now I should know this T flip-flop work in which clock pulse? The T flip-flop will work only during the edges. So can you see this is a clock pulse? Can you see this is a clock pulse? So it will work only in the edges. So which edge it will work? It will work only in the negative edge. Can you see what is positive edge? If it goes from 0 to 1, positive edge. What is negative edge? If it comes from 1 to 0, it is negative edge. It means this flip-flop will work only in the negative edge. That is why there is a bubble. Can you see this is edge triggered? If there is a triangle, it means edge triggered. If there is a bubble, it means it is negative edge triggered. Clear? So let us see the circuit. This is my circuit. I have drawn the construction of my flip-flop, construction of my 3-bit ripple counter. Now first flip-flop will be given what? Clock. Now see the clock. Okay, you know the clock. Positive, negative, pulses of positives and negatives. Done. I've drawn it. Now what is that I need to do? First I need to get the output in Q0. So I will start with Q0. Now this is my Q0. You should know that the flip-flop, T flip-flop will work only in the negative. Can you see the T flip-flop will work only in the negative edges. So in the clock, in all the negative edges, draw the arrow mark showing that the flip-flop will work only in the negative edge. First draw the arrow mark in all the negative edges. What is negative edge? If an edge comes from 1 to 0, it is a negative edge. If it falls from 1 to 0, it is a negative edge. Done. Now, how I can get Q naught? What is that I will get in Q naught? First, draw Q naught. Assume the first data is 0. First output is 0. Assume the first output is 0. Whenever you get a negative edge, the toggle flip-flop, T flip-flop. What is the name of T flip-flop? Toggle flip-flop. It toggles. If it is 0, it toggles to 1. If it is 1, it toggles to 0. Now what is there previously? 0. So it toggles to 1. It will be in 1 till which state? Till I get a negative edge. Can you see? Till I get a negative edge, it will be in the same state 1. Again, there is a negative. Whenever there is a negative edge, immediately 1 will toggle to 0. So again I will be 0 till which point? Till I get a negative edge. Since I get a negative edge, what I have to do? 0 will toggle to 1. I will be in the 1 till I get a negative edge. In this negative edge, what I will do? This, since it is 1, previous 1, now it gets toggled to 0. So I will be in 0 till which time? Till I get a negative edge. Now what I do? Since I get a negative edge, what I do? 0 will be toggled to 1. So I will be retaining in the same state till I get a negative edge. Now I have got a negative edge. 1 is toggled to 0. I will be in the same state till I get a negative edge. 0 will be toggling to 1. I will be in the same state till I get a negative edge. Now what happens? 1 will toggle to 0. I am done with Q naught now. Okay. Now we will see what is Q1. So what is Q naught? I will, whenever there is a negative edge in the clock, during that time what I do? What was the previous state? That will be toggled. So here previous state was 0. I assumed it to be 0. So I toggle it to 1. Till which time I will be in 1? Till I get a next negative edge. So see, when I get a next negative edge, what is there previously? 1. Now it is toggled to 0. Till which time I will be in 0? Till I get a negative edge. This has to be done. Now do for Q1. How will I get my Q1? Can you see output Q naught of first flip-flop will go as what? Clock of second flip-flop. So for Q1, clock is Q naught. So Q naught will be the clock for Q1. Is it clear? Q naught will be the clock of Q1. So this Q naught signal will act as a clock of Q1. So you know, whenever I get a negative edge, only then I react. Otherwise I will not trigger or I will not react. So what happens, since it is clock, I will not check this clock, I will check only Q naught. So I started with what? 0. I will be in 0 till I get what? Negative edge. When I get a negative edge, what I do? I toggle from 0 to 1. I will be in 1 till I get what? Negative edge. Where is my next negative edge? Here. So I will be in 1 till I get my negative edge. Now what I do? I got a negative edge. So what I do? Immediately I toggle from 1 to 0. I will be in 0 till I get what? My negative edge. This is my negative edge. Since I got a negative edge, I toggle from 0 to 1. I will be in 1 till I get my next negative edge. So I will go till here. Now since I got a negative edge, I will toggle from 1 to 0. So clear. For Q naught, this is a clock. For Q1, Q naught acts like a clock. So when I do the transition from 0 to 1 or 1 to 0, only during the negative edge. Can you see? This is my negative edge. 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 So I change during my negative edge from 0 to 1. In this negative edge, 1 to 0. In this negative edge, 0 to 1. In this negative edge, 1 to 0. Done with Q1. Now go to Q2. In Q2, Q1 acts like a clock of Q2. It means this Q1 acts like a clock of Q2. Now can you see in this clock, where is the negative edge? Where is the negative edge? Negative edge is here. Till this point, I will not change. I will change only in the negative edge. So 0 remains same till I reach my negative edge. Whenever I reach negative edge, what I do? I move from 0 to 1. I will be in 1 till I reach what? till I reach my negative edge. What is my negative edge? When I move from 1 to 0. So this is one negative edge and this is one more negative edge, right? So since it is 0, whenever I encountered first negative edge, I moved from 0 to 1. I will be in the 1 till I encounter my next negative edge. So I got a negative edge, so I move from 1 to 0. Zeros are lows, ones are highs. Zeros are lows, ones are highs. You all know that zeros are low, 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 low. Ones are highs. Okay. Now can you see this? 0, 0, 0 is 0. 0, 0, 1 is 1. 0, 1, 0 is 2. 0, 1, 1 means 3. 100 is 4, 101, 5, 111, 6, 111, 7. Clear? And 000 means 0. So what type of counter is this? Up counter. What is up counter? It counts from 0, 1, 2, 3, 4, 5, 6, 7, so on. Why? From 7 it has become 0. It is 3-bit counter. What is 3-bit counter? What do you mean by 3-bit counter? 3-bit counter means 3-bit ripple counter means what? It can count only 2 to the power of 3, totally 8 states from 0 to 7. After 7 it starts again with 0. That is why we call it as 3-bit ripple counter. If it is 4-bit counter, it counts from 0, 1, 2 till 15. After 15 it starts back with 0. Is it clear? So this is the design and working of 3-bit ripple up counter. Okay, thank you.